Good morning, everyone, and welcome to our webinar. We're excited to introduce you to NavTech Radar and our award-winning Clearway 360-degree radar-based situational awareness solution. It is a field-proven solution which has been deployed on a large scale throughout the United Kingdom, Europe, and other parts of the world. Clearway is unique in the sense that it is the only ITS detection solution that includes the complete range of automatic incident detections, has vehicle, bicycle, pedestrian, count and classification features, includes travel time determinations for either or both directions of travel. It is flexible in terms of the mounting and positioning possibilities of our sensor, and it is non-intrusive to the roadway. It's designed to be maintenance-free for 10 or more years, and Clearway is now available via our authorized partner channel throughout the United States and Canada. So with that being said, let's turn it over to our UK-based team, and Rebecca James will start.
Thanks. Yes, so I hope that everybody can see my screen. So yeah, good morning, everyone. So I'm Rebecca James. I'm the ITS Business Development Executive for NavTech Radar. And I'm also joined by Kieran Marsh, who's our Technical Project Manager. So a key area of my role is working closely with road authorities and concession owners to understand the issues and priorities that they're facing and how technology can be implemented to overcome these challenges. Kieran leads our ITS project delivery team and has a wealth of experience and knowledge in delivering this technology across the world. So we're going to be discussing why radar technology is being implemented in these ITS environments, the safety, efficiency, and environmental benefits, and how it can provide multiple capabilities from a single sensor. We'll then cover some case studies of real-world deployments and the results that we're achieving, and then we will have time for a Q&A session at the end. So I thought it was important to introduce you, first of all, to NavTech Radar and highlight why we're best placed to be delivering these successful ITS projects. So NavTech Radar have been implementing radar installations since 1999, and we actually started in the industrial automation sector, We delivered the world's first fully automated port in Australia. And so within NavTech, we have three core application sectors. So ITS, which I'll be discussing with you today, as well as continuing our work in the industrial automation sector, and then also security. So we provide wide area surveillance and perimeter protection across the globe. So across these three sectors, we have nearly 5,000 sensors installed in over 20 countries. And our focus is on continually improving and developing the radar technology that we have. And over 70% of our employees are actually engineers. So every element of the radar, from hardware and software development through to production and project delivery, and finally customer support, is still all done in-house at our headquarters. So it gives us the ability to fully manage a project start to finish and embed any customer feedback that we receive into the product roadmap. But why are road authorities looking at implementing new technologies? So as the number of road users continues to grow, risk levels remain high, and the National Highway Traffic Safety Administration announced in January that motor vehicle crashes cost American society $340 billion a year. When quality of life valuations were also considered in that total, the value increased to nearly $1.4 trillion. We can't keep building new roads at the same rate of road user growth. So of real importance is the ability to understand everything that's happening on the freeways. Past implemented technologies gave us a snapshot of what was happening on sections or areas of road, but we're able to gain that full picture of the roadway. So how are we able to gain this view? So this is our 360-degree rotating radar, the KTS 350X. I appreciate it doesn't look much situated on the side of the freeway in this image, but this unit rotates 4 times per second, collecting over 1.4 million points of data per rotation. which creates a high resolution image of the road. It's designed and manufactured to withstand extreme temperatures, dust, debris, water, and it has a compact design, so easy shipping, handling, and installation. And as you can see here, has been mounted to existing infrastructure to ensure project costs are kept to a minimum. So I'm sure the next question will be, so how does it work? What does this actually do? So radar systems work by measuring the time of flight from when a transmitted signal leaves the radar, hits a reflecting target, and returns back to the radar. This image is a still from a toll road installation that we did in the United States. So the purple circle that you can see is your field of view from the single sensor, which really highlights the range that we're able to achieve. We then narrowed down the coverage by manually configuring the carriageway within our Clearway software. So the green that you can see on the left-hand side, that's the raw radar data. So that's completely unprocessed, straight from the radar, but you can see that it's covering across multiple lanes. So in this instance, there's 4 open freeway lanes and 2 express tolling lanes, and that's in both directions. So you have a total of 12 lanes. And then on the right-hand side of the image is once we've processed this raw radar data, so we put it through our Clearway software, and you can see we're tracking vehicles and their direction of travel. So the Clearway software is completely configurable. So alarms are rules-based and can be set up in particular lanes or zones. You can have multiple alarms and multiple zones activated. And so the blue sections that you can see just close to the middle is where we set up counting classification zones. So on this specific project, dynamic toll pricing was used. So the cost of using those express toll lanes fluctuated depending on the volume of traffic across the open freeway lanes. When you're amending your express lane pricing due to peak times, it's essential that the data driving these price changes is as accurate as it possibly can be. So this is an example of one of our applications. So having that rich set of actionable data mixed with the configurable software allows us to offer multiple applications, and I'll cover all of these shortly in our capabilities. So with 360-degree rotating radar, you have up to 500-meter radius detection, the entire freeway with one sensor. So you've got coverage in both directions, covering as many lanes as required. Rotating 4 times every second, so you have high range resolution and accuracy. The radar detects, identifies, and tracks each object. So this gives you data not just when an accident has occurred, but potentially collision-causing objects such as debris in the road. And radar also works in the harshest of conditions, so when an incident is more likely to occur, so heavy rain, snow, bright light, complete darkness, and even smoke. So due to its high range resolution and accuracy, the Navtech radar sensor produces an extremely rich set of data. Being able to see your entire roadway with this data-rich image allows us to offer more than just instant detection. So we can provide an abundance of capabilities from the same sensor. So this includes wrong-way driver detection, so detecting and tracking movements of drivers going against traffic and allowing operators to take the necessary action by closing lanes and contacting the authorities. Detection for safety, such as pedestrian detection, debris detection on the roadway. We offer emergency situational awareness, which allows easy sharing of key incident data directly with emergency responders. This is particularly useful in challenging conditions such as tunnel fires. For traffic management, we provide counting classification, so to analyze real-time road use, and queue detection, so if the traffic volume reaches a set level and the average speed falls below a minimum speed threshold, Clearway can raise an alarm to the operators. So being able to offer the number of capabilities as we can minimizes the need for several different technologies roadside, so reducing the overall cost of the project and the infrastructure required. So where are these sensors deployed? So how are we seeing these efficiency and safety benefits from the technology? So a road operator is primarily measured against how well are my roads running? Are they serving the community members that are using them? So according to mobility analytics firm INRIX, the typical US driver lost 51 hours to congestion in 2022. That's about an hour a week. And that was 15 more hours lost in congestion than in 2021 and cost the average American driver $869 in lost time. However, the evidence is clear, just simply building more roads is not always a viable option. So we're installed on the Kwinana Freeway in Perth, Australia. So this is a 13-kilometre stretch of road that was Australia's first smart freeway. So Main Roads, Western Australia, wanted to use technology to maximise their existing road capacity. We were installed primarily for our automatic incident detection capabilities. So the core reasoning for them to create a smart freeway was to improve traffic flow on the road by detecting crashes and breakdowns. So helping emergency crews to clear the road quicker and get traffic moving again. So safety and efficiency of the freeway was paramount. The smart freeway has reduced the journey time of commuters by 10 minutes per journey per day. So singularly, that may not seem a very large number until you realize that's 3 days a year extra you get to spend at home if you commuted every day, and that's per individual per day. The scheme's been viewed as a great success both by the end customer and also the general public, and we're actually in the commissioning phase of their second smart freeway project with us. So as I mentioned earlier, radar technology performs in the harshest of conditions. So Sweden gets extreme weather during the winter months, and this has posed a real issue for the road authority there. So on the E4 motorway, the difficult driving conditions experienced by drivers, so snow, rain and fog, were leading to higher than expected numbers of slow or stopped vehicles, and then in turn a greater number of vehicle collisions. So the authorities were relying on operators to spot the incidents on CCTV or wait for the incident to be reported by phone. This was just proving not to be effective to detect all incidents quickly, and the operators were just not provided with enough information and, crucially, enough time to deal with situations before they escalated, for example, a secondary collision. So many different technologies were considered for the project, but knowing that video-based technologies were hindered by the adverse weather, Navtech Radar was awarded the project. So we were installed to automatically detect slow or stopped vehicles, pedestrians, and debris. And integration was an important element of this project as well. So our Clearway software was integrated with their existing SCADA system. So the system also integrated with existing video cameras to automatically direct the nearest camera to provide a view of the incident. So the Ryfast tunnel in Norway is actually our single largest installation to date. So we have 102 radars covering just under 30 kilometers. So the key requirement was to increase safety in the world's longest subsea road tunnel. So our system's providing a number of capabilities from the sensors. So we have automatic incident detection, stopped vehicle detection, pedestrian detection, and wrong-way driver detection. We've also integrated with the installed cameras so that as soon as an alarm is raised, the cameras are automatically directed and will record the incident for 30 seconds. So this means that with no intervention or additional work, the operators in the control room can instantly see what's happening. Wrong-way driving can cause catastrophic incidents, as we know, especially within a tunnel environment. And so our wrong-way driving alert will also automatically close the tunnel in this instance. So this prevents additional traffic entering and being involved in a high-speed collision. So tunnel environments have additional safety concerns. So as well as detecting incidents, our Navtech radar system gives emergency teams full situational awareness when they are responding to an event within the tunnel, such as a fire. So the tunnel can actually take up to 20 minutes to drive through, and we provided our situational awareness feature, so providing a visual map of the area with all the movements appearing on the map for visual information to coordinate an emergency response. We're also really excited to announce we've been selected as the automatic incident detection technology for a major highway corridor in Maryland. So this will be our first large-scale installation in the USA, and we'll be providing multiple capabilities to improve journeys and advance safety. So we'll be delivering stop to vehicle detection, automatic incident detection, count and classification, slow vehicle detection, and wrong way driver detection. So we work with a very talented and experienced team to deploy and commission these systems that I've been speaking about. So I'm going to hand you across to Kieran, who will talk you through the stages of delivering another large road infrastructure project, which is Transmission Gully in New Zealand.
Yeah, thanks, Becky. So just to give a little context for the Transmission Gully project, this was a new road connecting into the northern suburbs of Wellington, the New Zealand capital, based in the North Island of New Zealand. This road was built to bypass the existing coast road that went into northern Wellington that suffered from multiple closures over the years due to landslips. So this project had a lot of visibility in and around the New Zealand and Australia region. The project requirements were for automatic incident detection along the 28-kilometre stretch of the road, plus all the connecting ramps, some of which you can see in the image on the screen. Additional requirements were also for count and classification at major points along the highway and to monitor ramp performance for KPI reporting to the Traffic Authority. Commissioning of the radar system was interwoven with the building of the road, which provided its own challenges. We worked well alongside other contractors, including network architects, builders, and other software development teams. So it was a huge collaboration overall between many aspects of the road construction. So at Navtech, we have a well-established commissioning process that's flexible enough to fit into most project schedules, and Transmission Gully was certainly one of the most challenging. This can be applied on site using our own highly experienced engineers, but equally, as we did on Transmission Gully, we can train partners to undertake all of our on-site work on our behalf. Given Transmission Gully was commissioned during COVID, we were able to partner with a highly experienced ITS engineering team to work with installing and commissioning the radar system. So I'll just go through a brief overview of our commissioning process and what it looks like. So initially, we begin with a design. This is often undertaken at the pre-delivery stage to give accurate estimates of the number of sensors required according to the specifications of the project and the design of the road. All new road and retrofit programs, so retrofit means installing radars on existing roads, come with certain design constraints, and we work with the engineers to ensure that our system fits in with the project constraints. We've got many years of experience designing radar systems, and working alongside Navtech during the design phase is one of the most critical activities to ensure the optimal performance of the system, not only at the delivery stage, but also for the lifetime of the system. Many things must be considered during the design phase, and these include, but aren't limited to, things such as bends in the road, changes in elevation, locations of flyovers, bridges and signs, and many other things. So once we have a solid design, then we move on to site survey. So on-site survey confirms the design will work within the road environment. The radar, we mustn't forget, is a line of sight instrument, and many things such as signs, bridges, gantries and barriers can cause obstructions to prevent the effective detection on the road space. All efforts at the design stage are taken to mitigate these issues, but an on-site survey provides the final confirmation that the design is de-risked as possible by ensuring performance will not be hindered by any roadside infrastructure. Survey may also highlight required changes in the design that weren't possible to predict from the plans alone. So once we've surveyed and solidified our plans, then we move on to the hardware build. All radars are hand built by Navtech here in the UK by our dedicated manufacturing team in our manufacturing facility in the UK. Each radar goes through a series of stringent tests to ensure it's ready to go out on the roadside and remain operational for 10+ years. If physical servers are required, Navtech will build these to the required specifications before shipping. And system factory acceptance testing will also be carried out to ensure the supplied radars and the servers are configured correctly and working and communicating as expected. So once the hardware is built, been delivered and accepted by the customer, then it's on to installation. So once power and network and the mounting brackets are ready at the side of the road, the radars are ready to be installed in the design locations. Once installed, communication is then confirmed back to the servers. The next step quickly moves on to commissioning. This is the final stage of the roadside work. Here, each radar is correctly leveled to the road to ensure the optimal detection upstream and downstream of the radar, remembering that it's a 360-degree device. The first tests of functionality are also performed at this stage, where basic tests are performed by the on-site test engineers. So on Transmission Gully, the installation and commissioning were carried out by our local partner due to COVID travel restrictions. Navtech engineers were still able to connect to the software environment remotely to guide and to assist the on-site engineers roadside doing the radar commissioning activities. So then we move on to the final stages of the commissioning and doing software setup. The radar sensors are the more visible element of our system, but the software is lesser obvious, but equally, if not more powerful element to the entire Clearway system. The Clearway software is able to control all aspects of the radar system and how the signals from the radar are processed. Software setup is usually done remotely and was no different on Transmission Gully. Once vetted, Navtech engineers were given access to the Transmission Gully network to configure the system appropriately. Once the hardware and software have been commissioned, the system is ready for testing to demonstrate the required capabilities to the customer. This usually consists of recreating some or all of the required on-road events in a test environment to demonstrate detection of the radar and the correct passing of signals through the Clearway software all the way through to the traffic management system. On Transmission Gully, this took several months as testing followed the construction of segments of the road. This required the presence of all stakeholders to witness the successful completion of each segment of tests. These tests provide assurance to the customer that the detection of the system is functioning as required to the customer's specifications. The next stage is optimization, which requires live traffic to be flowing. Up to this point, everything has been done in a neutral or test environment. Having live traffic allows Navtech engineers to observe and respond to how the system behaves in all traffic scenarios. On Transmission Gully, this required a period of tuning and adjustment to ensure the operators were comfortable with the radar system. Once travel restrictions had been lifted, we were also able to send an engineer to spend some time with the road operators to explain to them and show them how the system worked and how our alerts related to what they were seeing on the road. This has proven to be an extremely useful exercise, not just on Transmission Gully, but on other projects too. The radar system requires some considered work when installing the system, and it is a critical area of expertise that we provide alongside with the provision of the device. This is done to ensure that no revisits to radar sites are required, which may impact road usage in future. So I'm going to hand you back to Becky, who will continue this topic and talk about how low impact our system is over its lifetime.
Thanks, Kieran. Sorry, I got a bit trigger happy at the beginning of the slides. So the safety and efficiency benefits of the radar are clear, but what environmental benefits can be experienced with this technology? So as you can see on the left, we know that queuing traffic brings increased environmental issues and that constant acceleration and braking is the primary culprit. So we look to tackle this in two ways. So one, we've recently removed all serviceable components of our radar. So as Irv mentioned earlier, our new motor, which was developed in-house by Navtech engineers, drives the rotating parts. This makes it service-free for its 10-year design life. And the radar sensor also requires no cleaning or additional maintenance. So that means less site visits, less shipping, less congestion caused by lane closures to complete the removal and the reinstallation of any sensors. It also means that once installed, there are no roadside works at all. So lowering the life cycle cost of the system whilst maintaining the same level of performance and reducing the environmental impact. And with radar technology, road authorities and concession owners can take a more proactive approach to traffic management. So understanding everything that's happening on the road to make decisions to increase efficiency, as we saw with the Kwinana Freeway project, and reduce that queuing traffic. They can also react quickly if an incident does occur, so clearing the road as quickly as possible and returning the traffic to its original flow level. So safety is at the center of everything we do at Navtech Radar, and we're really excited about how 360-degree radar is improving the ITS environment and its place in the road management ecosystem. As you can see, the solution is already trusted as the key technology to create some of the world's safest roads and tunnels,